Hello, we'll be talking today about package licensing and dependencies and their versions, and how we can try to improve a bit the world and make it a bit better around these few items. Let me share my screen. So, of course, package licensing matters. In a way, you could say that licensing is the essence of open source, right? No license, no open source. A quick word about me. I'm the maintainer of a suite of tools called DejaCode, and in particular from a scanner for license and packages called ScanCode. I like to think I am a Pythonista. At least I think I'm well versed in Python. I'm the co-creator of package URL and a few other stuff. I contribute to several other projects. Weird fact about me, one funny one, I have my sign-off attached to one of the largest deletion of code. And in the Linux kernel, sorry, largest selection of lines of code in the Linux kernel. Actually, these were really commands and not code. And these were actually mostly license commands. We're trying to clean up a bit the licensing of the kernel. And weirdly enough, you know, it's a skill. Being able to delete commands or replace or change commands in some cases actually broke the build of the kernel. So negative contribution to the kernel, but I think in the end it's a good one. All right, so the plan for today. We're going to look at the problems that has evolved across all the package ecosystem, and Python in particular, around license and dependencies, and how we've created a really mess of babel-like tower where everybody has its own ways to deal with license and dependencies when they are fundamentally the same, yet different each time. And see how we could find new ways to inspire and define new languages to reduce a bit the mess we have. In particular, I've been talking about package URL, version range specification, a bit about SPDX, and how we can potentially open with open specs, open code, and open data, work to work fixing all the things there. So we have somehow fulfilled the dream of our fathers, which was to enable software development using components, where you can assemble bricks and get started very quickly and assemble really beautiful application and systems from existing bricks. We call them packages. A few years ago, a typical app would use maybe up to 100 of these, large app. Nowadays, it's very common to see apps that have like thousands or 10,000s of such components, especially if you think about a combination of a backend app that would be based on Python with a front end in JavaScript, with a bunch of node packages, and everything being deployed, say with Docker images, you end up having very quickly thousands of packages with a combo of application and system packages. So that's great, except that at the same time, it's so easy, but we're really missing a lot of the essential things. We have little or few clear metadata. And if you don't have good information about the package that you're actually using, whether it's about license, version, security, and so on, automation is difficult. Well, difficult is a gentle word. It's borderline impossible. In terms of license clarity, which should be the first thing? I mean, the question when you use a package is, can I use it? And the answer is, what's license and what's your policy for this license? This information is badly missing. The other thing is, we don't have really a standard way to name and exchange information about packages. And we're talking about license and naming, but the same is true with package dependencies, as well as vulnerabilities, vulnerable range, and so on. The plan to fix this is, as I say, we're going to look at the way different open source package ecosystems deal with the documentation of license, copyright, and their dependencies, and see how we can come with some small elements to help fix some of these things. So, as I said earlier, no license, no open source, and that's really essential and important. And the big advantage of a free and open source software license over proprietary is because it has a name. When I say MIT or BSD or Apache or GPL, you know exactly what I mean right away. And you don't have to think about much. Either you think that's okay for you to use that or not. But this single word has been enough to help you understand what's a license, what are the implications of these license terms, and whether these are not with future policy. In contrast, if you look at proprietary software, there are like thousands and millions of different contracts, but pretty much every license contract is a different license, mostly unique. Now, we still have a bit of a mess because there's a lot of nuances. We wish, and I wish things were clean and tidy, and there were few of these licenses and license IDs. There's about 10 to 20 common ones, but it's still a mess, unfortunately. So let's look a bit at the license. Python first, right? There's package metadata. There are package metadata which are specified for use, whether it's setup.py, setup.cfg, or any kind of these end up in the end in the metadata file of a build package, whether it's a source distribution or a wheel. And we have essentially three things to available today: a license string, which is technically deprecated, a list of license file, and a list of license classifiers. These classifiers are a bit ambiguous because, for instance, they say BSD, and you really don't know whether it's a BSD with 2 clause, 3 clause, or 4 clause, these kind of things. So there's a few problems there. I'll come back to that later. Ruby can accept license string or a list. They say this should be SPDX license IDs, but they really don't explain how two license and lists relate. Do they all apply, or is it a choice? And whether or not they promote or say they should use SPDX, this is not enforced. Maven is also a list of name URLs plus comments plus something called distribution. And there's really no list, there's no defined ID and name, so it's a mess. Same thing for CPAN. NPM, having had quite a bit of history there, they started with a string, or it can be a list of IDs, or an object, basically a dict, or a pass to a file. It should be an SPDX expression, but it could be custom IDs, and so on and so on. And the same applies to pretty much all the package environment, be they application package or system packages. Sometimes you see a very strong influence of the programming ecosystem, programming language and environments on how metadata are carried around. For instance, in the case of R, they're using custom IDs together with mathematical notation for expressions, and they can expand license versions. So they say, for instance, this is LGPL superior or equal to version 2 or inferior to version 3, which basically means version 2 or 2.1. Of course, when you see that, that's a bit complicated to understand. Especially you need to understand that some versions of some license have ways to allow future versions or not. That's part of some of the more complicated things about open source licenses. Going down further, you see that everyone evolved their own stuff. There's a bit of an emerging common theme there, is that more and more we see SPDX license IDs being used. So it's a list of public license. And one of the co-founders of SPDX, by the way. But it's used in a very messy way or inconsistent way across all the different ecosystems. NuGet, for instance, historically has been using licensed URLs. In some case, something like a short URL, which meant that license could potentially change under this URL over time. It's something they're fixing, but there's still quite a bit of legacy to cope and deal with. I guess if you think that something like Go, at least they didn't make any extra mistake because they decided to say, well, there's no license metadata. This way, at least, there's no more mess. They just have a convention that there should be a file called license, uppercase, that's at the root of the project or code repository. That should contain licensing information, that's it. At least from a metadata perspective, it's unstructured, but it's eventually discoverable by the tools like the ones I make, but no more mess. Now, if you go down into projects, I was privileged to help the Linux kernel maintainers deal with a bit of clarification and rationalization of the licensing of the kernel. When we started, I found there was about 600 different ways to write this file under the GPL in the Linux kernel. So technically, you could probably go up to 800, but roughly 600 is a good number. And you had really weird stuff. For instance, there's used to be the person that contributed the code for the thermal drivers, which deal with temperature sensors in the Linux kernel, some driver for that, which released his code under the terms of the GPL. Of course, that's cute, that's funny. The problem is that when you have like not one, but hundreds of these, that becomes a total mess. Of course, it is, and it was. I've seen outside of the kernel something which was an external contribution where somebody was really GPL shy and was writing down a module license using the ASCII codes such that it couldn't be easily grabbable. Of course, that's pretty silly and fairly easy to discover, yet that's the kind of things you see. Or in some case, it can be very terse. Could be just the word GPL. And that's a problem because in some case, GPL, for instance, in France, would mean liquefied petroleum gas, GPL. That's not the license, of course. There's an energy utility in, I think it's in the Caribbean, which is called GPL also. So there's a lot of opportunities for mistakes when you have these very short statements, but you still have to account for them. And so trying to cope and solve all that, ideally you want to create a mapping so you can know all the different ways the license is being written down as a code, as an ID, or as a text, to a set of normalized, well-known IDs. And eventually, there's subtle conventions that you would like to capture. And so that's one of the way. The problem is that in many cases, it's difficult because there's a lot of ambiguities there. So we're still working on solving this, but the way we worked on that was to build a tool, which is a specialized search engine, which search for a large query, which is your own code, for a limited number of things, which is an index of 30, 40,000-ish license notice text, mentions and tags, and using a bunch of different matching techniques. It's all written in Python. There's a bit of C for performance, but it's pretty advanced as a tool there. It's called ScanCold, and it's really considered the industry leading and standard tool. I'm very proud of that. Of course, it's open source. There's still a huge amount of work left to do to automate everything. There's a lot of ambiguities that we're working on, sometimes false positives. And every time you have a false match and a false positive, you're making a big disservice to your users because eventually they will have to do more work to review the results of your tool. It's not a good thing. Copyright sounds very simple, right? It sounds extremely simple, except that in practice, there's only, if there's only like a copyright name, statement, a name, and dates, what you find really is that everyone has been using any possible permutation of these. So much so that we had to write a natural language parser, which is based on a subset of an LTK that we had to fork to specialize for this purpose, with a grammar which has roughly 1,500 lexing rules and about 300 plus parsing rules. So it's mostly a solved problem, but just to explain the complexity of this. Now, other problem, it sounds like mundane, but I'm sure you've seen that. Maybe you've done that, and that's bad. Come January, somebody comes and says, oh, it's a new year. Let me update the copyright years across the whole code base. And it's something you see all the time. And I'm sure you did it. I did it in the past. This is a very bad idea for many practical reasons. First, you're creating a lot of churn in your code. Second, the copyright duration is roughly 100 years. So forget about it. 100 years from now, it's your copyright, it's still valid and stands. That's great, but let's worry about this problem in the future. In any case, it's unlikely the year that you put in the file will be something that's considered as authoritative. If there's really like something like a lawsuit and a case, version control would be a much better solution. Especially copyright are helpful affirmative statement origin. So I'm not saying don't use copyright, I'm saying don't use yours. Instead, use yearless copyright. And there's more and more projects which have switched to this. Or you put a year and you never use that. But updating years every year is a bad idea. It doesn't serve any purpose. It creates churn. It creates walls of changes in your version control history. So please don't do that. All right, let's look at versions now. And so versioning, there's two primary use cases. The first one is I want to resolve package dependencies, and I require a version or version range. The second case is I need to know if there's a vulnerability that affects a certain version of a package, typically version range. And I really wish that version numbers should be boring. But in practice, every single ecosystem came with their own way to deal with the simple thing of saying this version is superior, inferior, or equal to something. In an ecosystem, in some cases, you have multiple ways. And I'm talking to you, Python. And each of these tools do resolve a dependency in a version range differently and have very subtle differences, subtle but important, on how you can decide whether a version is older or newer than another version. Okay. So the thing is that if we don't have a common way to talk about licenses and dependencies and copyrights, it's a mess. So let's look a bit at the things we're trying to do. The first thing, and that sounds like a bad idea, is coming with new standards. You would say, okay, right, one more standards, that's how standards proliferate. The experience I have concretely is that there are some standards that can help subjugate other standards and replace them and unify them such that you don't end up with more mess than before. Let's look about naming. And naming is really the essence of the problem there. License name. If you say GPL and somebody else says GNU public license or general public license, are we talking about the same thing? Yes, we are. What about the exact word you want to use for that? It's not crazy complex, but it's super important because, again, each time you use words you don't have a definition for, you're basically creating a new bit of mess. So SPDX came with license IDs. I maintain a license database called the Scan Code License DB, which has like several hundreds of these. It's public, it's open source. It's probably the largest data set of license in the world. I'm not too proud of it, but yes, I'm proud. Not too proud that I wish we wouldn't have to do all that, but it's useful in any case. Software package names. Think about that. You could have a package called file in Python, a package called file in Ruby, and a package called file in Debian. And these are not the same, right? Maybe file in Debian is the libmagic meta package, and file in Python and PyPI is something else. So I came with a very simple standard, which is called package URL, and that you can see here. Actually, yes, here on package URL, which eventually is the de facto standard for referencing packages, be they a Docker image, a Debian package, or a PyPI package. It evolves based on the need we had to identify package when we parse manifest and reference dependencies. It became fairly popular for identifying packages in vulnerability database. In particular, it's used now in the Open Source Security Foundation OSV. It's used at OWASP, the Open Web Application Security Project. It's used in CycloneDX. It's used in by Sonatype in their security vulnerability database. It's used by Encore and many more. It's very simple, but it's a way to uniquely identify a package using conventions which are based on exactly what you would expect it to be. It's an obvious way to relate a package, and that was badly missing. We're working now on something for version ranges. It's a sister spec to package URLs. And the thing here is, there's a library too. The question here is, how can you express a version range in such a way that it's, from a syntax perspective, it's the same across all the package types? Because otherwise, it's a total mess. You cannot compare two versions if you don't know the syntax of the expressions and the semantics of how to compare to version. I wish everybody would be using semver, but that's very far from it. And so the idea there is very simple, very simply to say, hey, this is how I can express a version range. Here, I'm saying this is an NPM version that's either version 1.2.3 or a version that's superior to 2 and inferior to 5. How you express then the comparison is going to be specific to a type. Of course, we call that a version scheme, and it's exactly the same concept as the package URL type. It's been adopted, of course, by some of the tools I'm working on, but it's also been adopted by CycloneDX. And again, the point here is that this small way to name things can go a very long way. When it comes to vulnerability names, the National Vulnerability Database provides what's called CV, a common vulnerability enumeration, which is an ID that's centrally assigned to vulnerability. It's not perfect, but it works pretty okay. And pretty much everyone creates their 3-letter acronym ID on top of that, but they map usually fairly well to one or more CVs. So it's not mostly completely solved, but it's working pretty well. At least we have mostly a way to define a common name for everyone. And last would be what would be a version control system pointer. How can you reference, say, a URL in a Mercurial or Git Subversion repository or whatever will come up in the future? And actually, pip came with something which is fairly elegant for that. You may have not used much of it, but it's there. You don't use that all the time, but it's useful. It's also been adopted in SPDX, and that's candidate to provide a common way to reference a version control system, including a potential commit or revision in that control system and a path inside. All right, now what can we do now to fix all the license? I think we need to go upstream. There's been an attempt to try to fix package by creating a central database of everything. I don't think that works. Instead, the idea is to say, let's build a tool that can understand all the license and normalize this. And that's scan code, which is essentially, think of it as a license and copyright linter, the same way you could have code quality and code lints. Here you could have license lints or copyright lints. Then once you have that, is you want to scan each and every software package to ensure that you have clarity in licensing. And then rather than keeping it for you, you go work with each of the maintainers of this project, because it's typically in their best interest to help them both fix the licensing if it's a bit ambiguous, and also ensure that they could deploy potentially linting by running a tool like that to ensure there's no drift. So that's in progress. Eventually, we're looking for some funding to help do that on large scale. The point is potentially to solve licensing once and for all, so it becomes an absolute non-issue. We've also worked on some tools to apply machine learning, not so much on license detection itself, because it doesn't really work there, but it's more to determine whether there are issues in the ambiguity or inconsistency of the license that we detect in a given package. And there's another piece of work, which is to work with each of the package ecosystem such that they can adopt shared conventions and shared IDs, typically SPDX. I'm the co-author of a PEP for that, which is 639, which is a draft. It's been out there for almost 3 years now. I'm very ashamed not to have been able to finish this, but it will be finished eventually. The point is that would be a way to adopt standard license expressions in the licensing of Python packages, which would remove any ambiguity about licensing in the vast majority of the case. The other thing is work with larger communities also to improve massively the licensing of packages. And there's eventually a campaign that I like to organize with large communities like Debian, for instance, or Alpine, to help scan, review, and fix all the package, both at the distro level, but also for all the upstream package that they have. And there's a lot of them. So there's a big leverage when we work with these larger communities and ecosystems. Leverage is good. Other things we do, and I've been working on to help things, is, weirdly enough, there's little or no free and open database of vulnerabilities. When I'm talking about vulnerabilities, it's known vulnerabilities of open source packages. There's something called the National Vulnerability Database, which is maintained by the US government, which is decent, but doesn't have everything. It's not only about open source, and it's also about hardware. But weirdly enough, there's no such thing. So we built this database. It's almost finished. We received some grant money from NLNet in the Netherlands and the EU to support this project, which is great. It's a team of volunteers. Eventually, we're building a free and open correlated vulnerability database together with the tool that's really fully distributed and available for everyone. We really think that software security information should be free. I mean, you don't want to put a tax on oxygen and prohibit the people to breathe. That's what I think vulnerabilities are there. And that's going to be more and more important. I mean, there's not a couple of months that pass by these days without major vulnerabilities being discovered. Being able to surface these, share them, make them available, and allow very quickly to check if your code has any package that has any of these vulnerabilities is going to be super important. Super important today, more important tomorrow. We talked about the license DB. And we're working also on a database of all the package metadata and dependency. Again, the point would be to provide that as a shared community resource, but also help whenever possible to fix and clarify things upstream, especially when it comes to the license. That's pretty much it. So if you want to help, the biggest thing you can do is ensuring that your project license, versioning, copyrights are clear, simple, and discoverable. There's no ambiguity. You can run ScanCode Toolkit on your project. I think if it can be discovered with ScanCode Toolkit, it likely will be discovered by anyone that cares, about these topics. Everybody should care, but some care more than others. And it's easy, make it easy, simple, and clear for everyone. The same way you'd like to have code that compiles and runs, make sure you have license, copyright that just compile and can be discovered by a tool like ScanCode. You're welcome to contribute code time and money, and you can find us online. And that's it. Thank you very much for your time. And I really appreciate the discussion that's going to take place this week, and I look forward to it. Thank you. Bye now.